and welcome to our today's ASHRAE Falcon Chapter webinar. My name is Sandra from ASHRAE Falcon Chapter, and I would like to thank you all for joining. I would like to remind you about our code of ethics. In this and all our ASHRAE meetings, we'll act with honesty, fairness, courtesy, competence, inclusiveness, and respect for others, which exemplify our core values of excellence, commitment, integrity, collaboration, volunteerism, and diversity, and shall avoid all real or perceived conflict of interest. Before we start, I'd like to go through our disclaimer. The information contained within is presented by ASHRAE Falcon Chapter as a supplier stakeholder webinar. It presents information of current interest and to provide a venue for interaction between ASHRAE Falcon Chapter members and the different industry stakeholders and the webinar presenter. These webinars should not be considered peer-reviewed or the final word on any subject. ASHRAE Falcon Chapter has not investigated, and ASHRAE Falcon Chapter expressly disclaims any duty to investigate any product, service, procedure, design, or the like, which may be described herein. The appearance of any technical data or editorial material in this presentation does not constitute endorsement, warranty, or guarantee by ASHRAE Falcon Chapter of any product, service, process, procedure, design, or the like. And now I'd like to introduce our VIP speaker for today, Hassan Younes, co-founder and director at Griffin. Hassan holds every certification you might think of from ASHRAE and Association of Energy Engineers. And actually, he's now an ASHRAE trainer at the Global Training Center, a certified trainer by the Association of Energy Engineers, a trainer at EGBC, and an appointed consultant for the ASHRAE 62.1 standard. And finally, he's our ASHRAE Falcon Chapter president. Today, he will be speaking about measurement and verification, so we can learn more about M&V options as per the IPMVP, practical example of adjusting the baseline to the weather change, etc. It's actually a very interesting topic where we can quantify savings for any ECM in a scientific way. I'd like to remind you that if you miss anything, just don't worry, a recorded version will be available on our YouTube channel. You can also download the presentation from the handouts. We will be running at the end a live Q&A session. And please feel free to drop your question during the presentation in the questions box. All attendees will receive a certificate of attendance within 48 hours. I leave it to you, Hassan.
Thank you, Sandra. Thank you, everyone, for joining today. So today we're going to be talking about M&V. The handouts are available. If you go to the handouts, you can see the presentation. Also, there is an Excel file of some data that we're going to be using. So you might want to also open that file, and later together we might do some exercise if we have time. So thank you everyone for attending. I'm gonna switch off my cam for now so we can have a better connection. So I'm not sure, are you able to see my screen now?
Yes, it is clear.
Okay. Yes, Hassan, it's clear.
All right, so let's start. So the context of today's presentation is to look at the fundamental factors driving energy savings. What is M&V? M&V options as per the IPMVP, steps to determine and verify savings, and then we're going to look at an option C baseline and savings calculation example, and then we're going to talk why do you need an independent M&V reviewer for energy saving projects. Now, when we look at fundamental factors driving energy savings, 2 weeks ago, I think maybe 10 days ago, we did a presentation on the energy audits. So basically, if you want to use energy in a system, in a building, you can look at two things. One is to try to reduce the performance or increase the performance basically, or get a better efficiency on a specific, let's say, equipment. And the second thing you'd look at is reducing the operating hours. As we know, energy is equal to kW times hours. I can either reduce kW and get a reduction on the energy consumption, or I can reduce the hours of consumption, or I can reduce both. So as we can see here on the screen, the baseline efficiency was at the top, and then the post-retrofit efficiency is reduced a little bit. Also, the hours per year have reduced from the baseline to the post-retrofit, and all that green area here is basically savings. So as you can see here, the area here is all savings. So that's due to a reduction of energy consumption because we have better efficient equipment or a better control strategy, and then reduced operating hours because we're reducing the number of hours that ECM or that particular system is being used. So ECM performance is the rate at which energy is used to accomplish a specific task, and ECM use is basically how much of the task is required. So to reduce energy consumption, preferably we need to look at both and try to reduce both. Now, what is M&V? What is measurement and verification? The most famous protocol we follow is the IPMVP, the International Performance Measurement and Verification Protocol. And their definition of M&V is basically, it's that the process of planning, measuring, collecting, and analyzing data for the purpose of verifying and reporting energy savings within an individual facility resulting from the implementation of energy conservation measures or energy efficiency measures. So that is the definition from IPMVP on measurement and verification. Too bad we cannot measure savings. You cannot really measure the savings, they're gone. So we measure energy consumption before and after and analyze measurements to determine savings. We cannot really measure the savings because savings do not exist basically. So the famous equation from the IPMVP is that the savings reported for any period is equal to the baseline period energy minus the reporting period energy. So baseline is basically what was happening before we implemented any efficiency measures, and the reporting period is when we installed and commissioned and ran those equipment based on the new energy conservation measure requirements. And plus or minus adjustments. We're going to talk more about adjustments, but look at the next screen, look at the next slide here. You can see that this is the baseline energy here. So let's say this is 2018 period. Okay, we implemented some energy conservation measures at this point. And here you can see there's a drop in the energy consumption due to these efficiency measures. And theoretically, these would be the savings here. However, let's say the 2019 was a little bit hotter than 2019. So we need to adjust the baseline, meaning that we're going to say what would have happened to the baseline, to the consumption during 2018 if the temperatures were a bit higher outside. And that is what we call the adjusted baseline. Anything that is different than what was happening during 2018 and is happening in 2019 in terms of maybe occupancy got higher a little bit, maybe occupancy got lower due to the COVID-19, as an example. If you're doing an energy efficiency project on a hotel, the occupancy is much lower. We have savings, yes, but that's not due to the energy conservation measures alone. They are also due to the lower occupancy. So we need to go back to the baseline and adjust it to say, what if the occupancy of the hotel was only 50%? What would have been the baseline in that case? And we adjust the baseline, and now we compare our consumption, our reporting period consumption to the adjusted baseline. This minus that will give us the reported savings. So the savings reported for any period is the baseline period energy, which is normally higher than the reporting period because we're trying to save energy, minus the reporting period energy, plus or minus any adjustments. Now, when you do an energy efficiency project, you have some energy conservation measures, The IPMVP give you four options to do the measurement and verification. Option A, in a nutshell, is retrofit isolation with key parameter measurements. We have two retrofit isolation methods, A and B. For A, it requires one measurement for the key parameter. As an example, lighting retrofit projects. Normally we use option A. Why is that? I have the lighting, let's say, in a building, and I change that to higher efficacy fixtures, let's say LEDs. I need to measure the LED consumption, so after the retrofit, and also I need to measure before the retrofit, so whatever I had type of lighting, incandescent or fluorescent, whatever, I need to measure their consumption, and then I need to measure the consumption after the retrofit. That is the key measurement, or the key parameter measurement is the consumption. I cannot use really the data from the cut sheets from the supplier. No, that's not acceptable. It's the key parameter that I need to measure that. In lighting, normally the hours, I can do a measurement on the hours before the retrofit, and then I can assume that it's going to use the same hours after the retrofit. However, for the energy consumption, I need to measure before and after. If it's the key parameter measurement is the power consumption. So I would measure before and after. So the fixtures before, what they were using, after what they were using, and then I can deduct that from that, multiplied by the number of operation hours. This would be the same. That's option A. Now option B is retrofit isolation with all parameter measurement. Isolation means, let's say I have a chiller. I'm changing a chiller. The boundary around the chiller is the retrofit isolation. In this case, is that I basically draw a boundary around the chiller, meaning I'm only looking at what's happening on the chiller side. What is the energy consumption? I don't really care how much I'm using in terms of lighting in the office building. I'm looking at that particular chiller in this office building, so I will put a boundary around it and would need to measure everything that's happening within that boundary. So let's say if I have a chiller, I would probably need to measure the power consumption. I would need to measure the tonnage produced or the kilowatt produced, cooling produced. And also I would need to look at the weather, because that also affects the performance of the chiller and the COP. I would also need to look at the supply temperature from the chiller, and I need to build a model around that for the baseline period. And then in the reporting period, I also need to measure all these parameters. So I'm measuring basically everything. Option B normally is more costly than option A because I have more measurements to do. Now, option C is the whole facility measurement, which is in project I've seen around the GCC. A lot of people use that. A lot of ESCOs go for that. It's a bit easier for them. Seemingly, it's easier because they will look at the whole consumption for, let's say, last year and compare it to the next year consumption after they've done the energy conservation measures. The problem here is that the adjustments are a bit scary, to be honest, because you need to be very careful. You need to capture all data that will change the consumption within that building. Because again, you're not looking at the chiller on its own, you're looking at the whole building. And then you need to make sure that you know exactly what's happening within the building during the baseline. And then in the reporting period, you need to go and check. You had, let's say, 20 DX units, they've added 5 more. You need to go there and do an adjustment for the baseline, saying that if those 5 DX units were there in 2018, what would have been the consumption? So it's a bit tricky from the adjustments. If, let's say, not a lot will change in the building, option C becomes very good. Also, option C, normally we use it when we have consumption above 10%, or savings, sorry, above 10%. Below 10%, it's not really viable to use it because you cannot see the savings. Also, we use it if you have interaction. So let's say you're changing the chiller plant, you're also changing the lighting. The lighting will also affect the chillers because it's a lower heat dissipation now. So instead of going in option B in every on the chillers, on the pumps, on the lighting, I go with an option C as an example here, changing the chiller plant and lighting. Now with option D is called calibrated simulation. We normally use it if we don't have any utility data. So I don't have any utility data. With option C, basically, I have the utility data. I'm normally comparing to the utility data, let's say from DWA, from whoever is the utility provider in your area. You have the data, and this is what you base it on. For option D, if you don't have the data, then you will create a model and would calculate from the model what would have been the consumption. Also, option D, if you've done any lead projects, normally you would use option D for measurement and verification for lead. In that case, basically, you would create a model normally during the construction of the project. And once you have the building is occupied, you start gathering data after occupancy, prepare the computer simulation to be calibrated. So you have, let's say, 1 year of consumption. You go back to the model, you calibrate it based on the gathered data. Compare it to the actual now consumption. Once you calibrate the model, then you create another model removing the efficiency measures, and then you compare it to the baseline, saying that without the efficiency measures, this is the consumption. With the efficiency measures, basically the calibrated simulation that you've done, let's say you're using, I don't know, 3 million kilowatt hour for the reporting period, and you remove the efficiency measures from the energy model, and the new simulation will show maybe 4 million kilowatt hour. In that case, you have 1 million kilowatt hour of saving. Not a lot of people use option D. You need a very talented energy modeler to do an option D. What I've seen here in the area, option C is mainly used. Option A for lighting. Some people try to do option B, but it's a little bit tougher in terms of the metering requirements and all the data that you need to capture around that particular energy efficiency measure. Now, what are the steps to determine and verify savings? First, you need to develop a project-specific M&V and define the baseline. I've seen a lot of M&V plans, a lot of them lack a lot of essential info. We're going to go through that. Then you need to conduct post-installation verification activities to make sure that things are running properly. And you need to perform regular interval M&V activities. You need to go to the building and check anything has changed in the building. And this is normally a responsibility between the energy service company and the owner. They need to share the responsibilities in terms of what are the things that needs to be captured. I need to capture the number of occupants maybe. I need to capture the production rate within the factory. I need to capture if any material changes has happened on site, anything has been added. A data center could be adding a lot of energy, and the owner could come and say, well, I don't see any reduction in my bill from the utility, but the ASHRAE will tell them, well, there was a data center that you've added, and that data center has caused this much of energy consumption. Now, it always is a good idea to add sub-meters so you can actually isolate that addition, but normally it's not possible. If let's say you're adding a few DX units and it's not, maybe becomes not feasible to add all these meters. But in general, if we have the ability to add meters, sub-meters, it will give us a lot of visibility on where the energy is being used. Now, the M&V plan should define how savings will be calculated and specifies any ongoing activities that will occur after equipment installation. Again, normally we follow the IPMVP when we are preparing M&V plans. A project-specific M&V plan includes the following details on each energy conservation measure and also looking at the project-wide items. So, ECM level items, overview of proposed energy and cost savings. You need to define what is the ECM, what is it going to do. Schedule all M&V activities related to the ECM, what needs to be captured. Witnessing requirements, you might need to go with the customer, get their sign-off that they've seen it and they're okay with it. Utility rates, what are the utility rates to be used? In some projects, you might have a different rate than what's being used for the from the utility for different reasons. Could be that it's a utility pilot project and they are using a higher rate just to decrease the life cycle cost of the project or the simple payback of the project. O&M reporting responsibilities. Who will do operation and maintenance? Normally, the ESCO will do the operation and maintenance on the ECMs that he worked on. Other equipment that he did not work on, and normally it's part of the client's responsibilities, but there should be a very clear matrix on who's doing what, basically. Now, project-wide items, details of baseline conditions. We need to know exactly what was happening in 2018, or if that was the year of the baseline. I need to collect all information in terms of documentation of all assumptions and all sources of data, how energy savings will be calculated, detail of proposed energy and cost savings, detail of post-installation verification activities. So I need to go do some inspections. Maybe it's all gonna be online. Maybe I have a very sophisticated BMS on site. I cannot check it online and see everything is working properly or not. But normally you would need to have physical visits to look at specific things and an equipment, or anyway, you need that to check if any static factors have changed, anything that has been added to the facility that you probably did not anticipate. Details of any anticipated adjustments to baseline or reporting period if we know that there are some specific items that we need to take care of, especially like occupancy in a hotel. So that you need probably a weekly update from the hotel or a monthly update to see the occupancy pattern and update the baseline accordingly. Also, you probably would want to show a format of the required M&V report, post-installation and periodic M&V. What kind of reports will be submitted by the ESCO to the owner? That is also very, very important in the M&V plan. Developing the baseline. The baseline information is used to estimate savings and account for any changes that may occur during the performance period. So if you download the baseline data, you would see that particular building had 2 accounts. That's the Dubai building basically, and you can see the consumption per month. That constitutes the energy consumption of the baseline. Normally it's 12 months if we're going with an option C. If we're going with options A or option B, that's different. It's based on measurements and periods as well. Baseline physical conditions are obtained through surveys, inspections, spot measurements, short-term metering activities, and may be verified using utility bills depending on the M&V method selected. After the ECM has been implemented, it's really not possible to go back and reevaluate the baseline because it no longer exists. We cannot really go back. If we change the chiller, we cannot go back and take measurements on the old chillers because it's gone. It's not possible anymore. So it's very important to properly define and document the baseline conditions, which is normally done during the investment grade audit. It needs to be very detailed so you know exactly what was happening during the baseline period. What are the things that you need to collect? Equipment inventory and conditions. I need to know exactly how many equipment are there in the building. If I'm using option C especially, I need to look at all kind of air conditioning equipment, computers, whatever is using energy. I need to have a list of that with the nameplate. What is the occupancy schedule, operating schedules, key energy parameter measurements, current weather data, and control strategies. We're gonna see an example at the end of an adjustment because some equipment has been added or has been modified or has been activated. Now, this is not part of M&V, but it's definitely a requirement. You need to have proper commissioning for the energy conservation measures to work properly. So you need to commission the installed equipment and systems. In an industry best practice, we normally follow ASHRAE Guideline 0 or the ASHRAE Guidelines or Standard 202 when it comes to commissioning. So you need to make sure that things have been installed properly, are functionally tested in all modes, and make sure that savings will be attained. Look at lighting levels, cooling capacities, kilowatt per ton, all these things need to be done. Now, that's not part of M&V, but it's recommended and it's required basically to make sure that savings will be attained. It's not an M&V activity. Now, conduct post-installation verification activities. These are done to ensure that proper equipment systems were installed, are operating correctly, and have the potential to generate the predicted savings. Verification methods include surveys, inspections, spot measurements, and short-term metering. It's not as extensive as the commissioning process, But that's basically to go there and take some measurements and make sure that things are running properly. So here's the difference between commissioning. So commissioning ensures that systems are installed as per design criteria and function properly. Post-installation M&V quantifies how well the systems are working from an energy standpoint in support of the cost savings projections put forth by the ESCO or the energy auditor. So these are the differences between the commissioning and the post-installation M&V. The post-installation M&V, we're looking mainly at the energy consumption, making sure we are getting the savings or not. Performing regular interval M&V activities. M&V must be performed at regular intervals to ensure that the installed equipment is operational and is delivering the savings that were proposed. So again, this is mainly due to look at any changes that are happening within the facility. With proper coordinating and planning, M&V activities that provide operational verification of an ECM during the performance period can also support ongoing commissioning activities. So if you have an ongoing commissioning activity like continuous commissioning, which is very rarely used around the world, to be honest, but if that's the case, these things could have some overlap, and you could basically provide some help as an M&V practitioner to the commissioner and vice versa. It is recommended that I honestly would recommend monthly report to report any activities that have been done on site and any changes. But maybe it's going to be cost inhibitive to do that. More frequent monitoring and or inspection ensures that the M&V monitoring and reporting systems are working properly and installed equipment are working properly. It also allows some fine tuning. It avoids some really bad surprise at the end of the year when you come to the client and tell them, oh, we did not really get the savings. We're trying to analyze the data to come up what's the problem. But it's better to get the bottom of it at every month, basically, to see what's happening, update what's happening on site. Maybe it's not your problem. Maybe that's something the client staff are doing, and that is also important to be done, so you cover your interest and the owner's interest as well. Now, I have some polls here that I'm gonna start sharing. So one of the questions, we discussed the different options, one, A, B, C, and D. So I'm gonna ask you a question on, I'm gonna launch the poll now. So the question here is, which M&V option is more appropriate if you want to change one chiller in a building, just one chiller? Should you go with an option A, an option B, C, or D? Remember, with the chiller, a lot of parameters that needs to be captured. It's not as easy as lighting. You probably will need to check the kilowatt per ton, check the temperatures, delta T, outdoor temperatures. If it was water cooled, maybe the wet bulb. If it's air cooled, the dry bulb. And remember, it's only one chiller. That's probably is going to be maybe less than 10% consumption of the building. Let's say you have 8 chillers, 8 air cooled chillers. You're only changing one, so only one chiller. Gonna keep the poll open for 90 seconds. Still have 30 seconds if you did not vote. So I think most of you got the right answer. So yes, option B is the correct answer for one chiller. Option C could be an option if that portion of that chiller is using a lot of energy. It's constituting more than 10% of the building consumption, which could be the case if it's only, let's say, 2 chillers in that building, then could be the option. So option C could be also used. I prefer to use option B because it's only one piece of equipment. Put all the measurements around it, try to get the savings on the chiller, because there are no interactive effects. You also save yourself from a lot of adjustments in the building. You still need to do some adjustments, but it will be less of a headache than compared to option C. So here we're going to go with an option C baseline and savings calculation example. First of all, let us define degree days. We always heard about degree days. What do they mean? Degree days, and normally we use a base of 18.3 degrees C or 65 degrees Fahrenheit. These are based on the assumption that when the outdoor temperature is around 18.3 degrees C, which is very true, especially for residential buildings, we don't need heating or cooling to be comfortable. So at 18.3 degrees C, you normally wouldn't need to turn on the air conditioner or the heater. In Dubai, anyway, we don't have any heaters in general, but or the UAE, we use normally cooling or the GCC. At 18.3, normally we don't need to use our cooling device, so no air conditioning will be working. So degree days are the difference between the daily temperature mean, which is the high temperature plus low temperature divided by 2, and 18.3. So it's a subtraction of the two. If the temperature mean is above 65, we subtract 65 from the mean, and the result is the cooling degree days. If the temperature mean is below 65, we subtract the mean from 65, and the result is heating degree days. Meaning if the temperature is below 65, we'd need heating. Above 65, we would need cooling. As an example, let's say the high temperature for a particular day was 90 degrees Fahrenheit, and the low temperature was 66 degrees Fahrenheit. The temperature mean for that day would be 90, which is the high temperature, the highest temperature in that day, and the low temperature, which is 66, divided by 2, it would give us 78 degrees Fahrenheit. So for that particular day, the cooling degree days is equal to 78 minus 65, which is the base temperature, equal to 13 degrees cooling degree days. So for that particular day, we have 13 degree days. So we need to count. If I need to get degree days for, let's say, June, I need to calculate the degree days in that case for every day of June, and then add them together. That would be the total cooling degree days in June. So I'm not sure if you were able to open the Excel sheet, but you'll see basically that information on the Excel sheet. As you can see, this particular building has 2 accounts, and this is basically, these accounts are serving the landlord area. So it's a residential building in Dubai, and these are the consumption. You can see here it starts from June to May, so it's covering 1 year of data, 12 months. That is we consider the baseline year from June 2018 to May 2019, because it's let's say it was the most recent when we worked on that project. And as you can see, account 1 is using around 1.8 million kilowatt hour. Account 2 is using around 1.7 million kilowatt hour, and this is the total build, is the addition of account 1 and account 2. And here you can see the build cycle start. Again, that's very important when you need to do any calculations when it comes to cooling degree days or any correlation. Basically, you need to make sure that the energy consumption conforms to the cooling degree days for that particular period. So in here you can see that the build start cycle for June is not 1st of June, it's the 9th of June, and it ends on the 10th of July. That's basically coming from the utility. This is when they collected the data. And in that case, I need to look at the cooling degree days that conform to that billing cycle. It's not I go to the website and check from 1st of June to 30th of June and get the cooling degree days for that period. I need to check this specific period. And I can use websites like coolingdegreedays.net and to get the cooling degree days. Or if I have a weather station on site, which and it's accurate and it's being calibrated, I can use that to derive the cooling degree days for the specific site. Normally, I would use weather stations like Dubai Airport or similar to get these cooling degree days. So here, as we can see, there's a total of around 7,461 cooling degree days with the base temperature of 65. So this is in Fahrenheit, basically. Full year, 366 days. and then this is the consumption of the building. Here you can see plotting the monthly profile from January to December, just to have a look at it, and look at the consumption, the pattern here. For every account, you can see here the account 1 and account 2, it increases during summer, decreases during winter, and here the addition of the 2 accounts, as you can see, it's very clear that in January is the minimum as well as in December, then it starts increasing as the temperature is increasing and it peaks around July and August. I have another question for you here, another poll. So this is another question. From this profile, what do you think is the main driver for consumption? Is it lighting? Is it ventilation? Is it air conditioning? Is it lifts? Again, look at the profile, the shape of the profile. As you can see, when most of the energy is being consumed, so yeah, I think everyone's getting it right. 96% got the right answer. Give it 15 more seconds. Whoever did not vote. All right, so everyone, almost everyone got it right. It's air conditioning. That's the main energy driver in that particular building. Now, if you look at the shape here, you can see that most of the energy consumption is happening during the hot months. There's a considerable increase here. So this is how, just from looking at that profile, we think that air conditioning could be the biggest contributor. Now, what do I do next? If I want to know if it is weather dependent and how much is it dependent on weather, I need to do a correlation between the energy consumption and the cooling degree days. And how to do that, I can open Excel, and maybe I can do that now. So this is the example that you have. It shows account 1, account 2, and the cooling degree days. If I select these two, and I go here, and go to recommended charts, and go to scatter, and then I would change the data basically to select this instead. And here the Y, let me select this. And I can add the trend line, linear, display the R squared, and display the equation on chart. And I get to this. What can I see here? I can see the equation. So if I go back to the PowerPoint screen, I can see the equation. Now you know how to do that on Excel. You can see here that the R squared is equal to 0.9462. R squared is basically the coefficient of determination. It means the higher it is, the more representative is that equation of the actual situation or the actual bills. Above 0.75, it means there's a high dependency. between that variable. The independent variable in this case is the weather. So that's the independent variable in this case. And in this case, I have 0.94, which shows a great dependency on the energy consumption with the weather. So the weather is actually driving the energy consumption in this particular building. Why is that? In that particular building, since it was covering landlord areas, most of the equipment were the chillers, the chill water pumps, some pressure handling units, some lighting for the parking and the corridors. So the main consumers are the chillers and the chill water pumps in that particular building. And this is why we have this high energy dependency. Now, as we can see, the equation is equal to 338.68 times the cooling degree days plus the intercept is equal 93,022. This is basically the base load. The base load is equal to 93,000, meaning that whatever I do, though it's not dependent on weather, I'm going to use that base load. And this slope part, which is the weather sensitive part, is driven by weather. As you can see here, this is the intercept. So 1.1 million is used during the year, which is not weather dependent. That is mainly being used by the lighting, by the fans. Whether it's cold and hot, they're going to be used. That energy is going to be used on the fans because the ventilation fans are not dependent on the weather. And let's say the parking fans not depending on the weather. The lighting is not dependent on the weather. Anything else in that particular building is more or less depending on the weather. So this is the equation again, and this is the total. So we can look at the total that we got from the model and compare it to the total that we got from the actual bills. There's not much difference. If the difference is less than 0.005%, that is okay for the model. It means the model can be used. Now, let's say I did the changes, right? And I have now the bills for the reporting period. So the reporting period consumption, I've done the adjustments or the energy conservation measures in May 2019, and I started collecting data of how much I'm using in June 2019 and onwards. As you can see here, the consumption per month has been collected from the utility bills. Now I need to look at that particular reporting period to see what is the cooling degree days on that reporting period and see if I need to do any adjustments for the baseline based on that. So the cooling degree days for June 2019 is 1,065 compared to 1,004 in 2018. It means it got a little bit hotter in 2019, and that means I need to adjust the baseline, meaning that if the temperatures were the same as we are having them in June 2019, in June 2018, what would have been the consumption? So I need to adjust the baseline using that particular equation. So if I go to the Excel sheet, and I would use the new cooling degree days to derive the new consumption for the adjusted baseline. Let me open another Excel sheet. Here we can see the new cooling degree days for June 2019, and then I'm using the same equation that I got to derive the adjusted baseline, which is equal to the base load is going to be still the same, 93,061, and the adjusted weather variable load, I'm using the new degree days multiplied by the 338.58. Adding these two together, this would be the adjusted baseline in June 2019. So now the savings would be equal to the adjusted baseline minus the reporting period energy, and the savings in this case equal to 103,528. If I use the 2018 value without any adjustments, I would have got a different number. So I need to do the adjustments to make sure I take into account the new weather data in 2019. So this is how I would determine. I can also maybe by email send you this, but it's really easy to compile. just basically use the equation to derive the adjusted weather variable load, and that would be the adjusted baseline based on the new cooling degree days that I've collected in June. And then the savings would be the adjusted baseline minus the reporting period energy. Now, let's go back to the PowerPoint. Here you can see, look at the savings that we're having. Look good in June, July, very good savings. September, something happened, 21,000. What could be the reason? Maybe we're using some, I don't know, water-cooled chillers, and the wet bulb is high during that particular month. Maybe we're using wet walls on air-cooled chillers, and since it was really humid, maybe something happened with the controls. Maybe someone played with the controls, decreased the supply temperature on the chillers, and we didn't have a lot of savings. However, if you look at October, it's really very low. It does not make sense to have such a value in October, and in November and December and all other months we're having higher savings. It means there might be something happening in October 2019. Now, because we are very good M&V practitioners, let's say supposedly we went to site during that month to see what was happening. We have collected, like I mentioned, every month we need to go there to see what's happening, any changes in the facility. Maybe something changed, maybe occupancy has changed. In that particular case, the change was basically what we call a non-routine baseline adjustment. What we've done with the weather is a routine baseline adjustment based on an independent variable, which was the cooling degree days. Non-routine is something that we really don't expect to happen, but it did happen. In this case, for October, what happened, yeah, it's actually instead of March, this is a typo, it should be October. So what happened here in October 2020 is that for 15 days, they have ran their parking fresh air fans. In that particular building, there are 4 fans, 40 kilowatt each, operating 24/7 for 15 days in October. And normally these are off and only the exhaust fans are running because the CO levels are never reaching high levels to a level where they need to turn on the fresh air fans. It's only one level of parking, so the exhaust fan were more than enough. However, during these 15 days, there was a foul smell in the basement due to some issue with the drainage, and they thought maybe they can add fresh air during that time to reduce the smell issues. So 15 days running 4 fans at 40 kilowatt. Again, for us to estimate the consumption, better to do the measurement on the fan to see what is the actual consumption. It's a constant speed fan. I don't need to really log it for a long time. I can log it for, let's say, for 15 minutes and see what is the consumption. 4 fans times 40 kilowatt for 15 days, it will equate around 57,600. So my adjusted baseline now, I need to go back, add to the adjusted baseline from the weather factor, add to that 57,600. That would be the new adjusted baseline. And this is where I calculate the savings. So the new adjusted baseline is equal to 323,663,000 or 323,663 plus 57,600 that is due to the addition or the running of the fans for 15 days. That would be the new adjusted baseline. And then my savings, and sorry, this is not March 2020, it should be October 2020, is equal to the new adjusted baseline minus the reporting period consumption, and that will give me the savings. So this is what we call a non-routine adjustment. This could be also additional occupancy. This could be also addition of, let's say, DX units. This could be change in the facility, adding a data center, adding more computers, changing PCs from, let's say, low consuming PCs to more advanced PCs that are using more energy. In that case, I will need to go there and count the PCs. Let's say it's the same number, so I need to just see what is the new consumption of every PC compared to the old one, assume or measure the period of time the PCs are being used, and then adjust the baseline accordingly. This is why option C becomes complicated. There are too many changes within the the building, if let's say the renovation is happening, it's really very hard to try to quantify the adjusted baseline. It really, best case scenario or the best way to do it, maybe build an energy model, and it's almost now combining option C and option D. It becomes really high cost to do that, and really the amount of efforts put in the M&V will increase the cost of M&V, and again that will decrease the savings because you're going to be paying for the M&V costs from the saving costs. Now I have another poll for you on the cost of M&V. What do you think is normally the cost for option C? So let me show you that poll. So this is in general for M&V costs. What is the norm? Is it between 10 to 20% of the project cost? Is it 20 to 30% of the project cost? Is it 1 to 10% of the project cost? Or is it 30 to 40%? Again, the higher the cost, it means it's more accurate. But again, do you really want to put a lot of money on M&V and lose from the savings? So you need to compromise between accuracy and cost savings. So how much cost I put into M&V, the more effort I put, the more meters I put, the more cost to the M&V, and the less savings I get. So it needs to be, there needs to be a compromise between them. I see most of you are getting the right answer. Again, it could be the approach from the client that he wants to have very, very accurate savings or very accurate measurement and verification process. He said, you know what, I'm willing to pay more, but I need to have very accurate results, very accurate saving determination. In that case, it's up to him. Here we're saying normally what EVO or the IPMVP normally are saying as per the part of statistics of what's been happening within the years and a recommendation of what the cost should be. Again, option A is less costly than option B. Option C is also less costly than option B. Option D, depending on the complexity of the project and the amount of time that's going to be put into the energy modeling, it also could be as costly as option B. So I'm going to close the poll now. So most of you have suggested 1 to 10%, which is the correct answer. Again, you can go for 10 or 20% if you want to have very accurate. If you want to add meters on every piece of equipment, the cost could go higher for the M&V. But normally people would tend to keep it below 10% because they're trying to save money on the project using more, more resources, putting more effort into the M&V. Although it's desirable, but it could be increasing the cost of that, and that might not be good for the project. Now I have another poll here. The question basically is, when should the M&V be prepared? When do you start preparing the M&V? Should you prepare it during the design of the ECMs? Should it be done after commissioning of the ECMs? Should it be done during installation of the ECMs? Or should it be done during the initial walkthrough audit? I'll keep the poll open for two. This is a very important question. So when do you start thinking of the M&V or actually preparing the M&V plan, that document that should go to the client for approval? Should it be during the design, after commissioning, during installation, or during the initial walkthrough audits? At the end of the day, you can do the M&V at any point in time, but there is a recommendation that M&V community would advise you to. Okay, I'm going to close the poll in 5 seconds. And most of you have got the correct answer. So during the design of these ECMs, it's really recommended to start and prepare the M&V. Why is that? Let's say we're going with an option B and we want to add meters. It would be good to have that part of the ECM package. So instead of, let's say, moving into the installation process, and these meters were not taken into account into that, that was not good for the project. You will have additional costs that were not part of the initial investment by the client. The client will not be happy. The ESCO will not be happy as well. So it's better to do the M&V during the design of the ECMs. Any meters have to go in. It should be done then. Okay, so this is, I think, the last slide of the presentation. Why do you need an independent M&V reviewer? What is the recommendation here? Do we need one or we don't need one? It's probably better to have an independent M&V. It really protects both the ESCO and the customer. I've seen a lot of issues happening from M&V between the client and the ESCO. The ESCO comes with these adjustments, and the client just either don't understand why these adjustments are happening, and sometimes the ESCOs maybe use wrong models, and that either exaggerate the adjustments or not capture them properly. They could be hurting themselves at sometimes if they're not using the right procedures and right calculation methods. So it does avoid future conflicts between both parties, the customer and the ESCO. So having a third party to vet these calculations, the M&V and the M&V activities and the reports, very important. It makes sure that energy efficiency is attained and is vetted by the third party. Again, if you're going to go public with that information, it's good to say, well, this efficiency project has been vetted by a third party. It's not just us and the ESCO claiming that we did those savings. It will also help the ESCO and the customer to prepare a really robust M&V plan and perform M&V activities properly. So in many cases where we've acted as an M&V, let's say, reviewer, we were very adamant that the client has some responsibilities. The ESCO need to go to site, and unfortunately, some of the ESCOs might not be, they don't want to put a lot of costs on capturing these baseline adjustment factors or the static factors, but it's very important for them and for the customer to do these things. So it's very good to have a third party to look into these things, give comments, and make sure things are being done. Also, in many countries, public programs, a third-party M&V reviewer is a must. There has to be an experienced also a company or a person to review these M&V plan or the activities and vet the M&V reports. I think we are done with the presentation where it's 2 p.m. So thank you very much, everyone. We can start maybe taking some questions.
Thank you so much, Hassan. Quite interesting presentation, actually. I have some questions here. Basically, they're asking about how to define your baseline in case you have high internal load building. How to establish your baseline.
If you have high what, sorry?
Internal load building. Your load is internal, not due to weather or...
So again, it depends mainly on what is the ECM rather than the actual conditions. Normally for industrial buildings, we would go with option B rather than option C. So if you're doing a specific ECM on a specific piece of equipment, better to isolate it rather than looking at option C. And again, the independent variable does not have to be the weather. In this case, it is the weather because it's what is affecting the consumption. It could be a production unit. It could be occupancy. So it doesn't mean that one independent variable. It could be 3 variables into one equation. So it's not really only one variable. It's not the weather always. It is the weather normally in residential buildings. It's one of the main consumption for the landlord areas. That's why we use it. But in an industrial facility, it could be the production rate. So it doesn't have to be the weather. So especially for high internal loads or industrial facilities, I would recommend to go with an option B rather than an option C.
Yes, actually, I have another question where I think you already mentioned this, but under which circumstance does option D become more relevant, cost-effective than installing meters for collecting utility data?
Again, option D, like I mentioned, if let's say you don't have utility, let's say in some buildings there are no utility meters, so we know that we're consuming something, we don't know how much, so we need to do this model to come up with that. Now, with a new building, so let's say for LEED we use IPMVP because the building still does not exist, and we need to do the model. So this is why we are using an option D for a non-existing building for a LEED project, because the building is still not there. So I cannot really put any meters. I need to do the model, and then I will calibrate it based on the sub-metering and the utility meters, like I mentioned in the presentation.
Okay, Hassan, I have a question here about option C and regression analysis. If it's enough to use only the previous year, or it's better to check 2 or 3 years?
It's better to check 2 to 3 years. However, if you go back a lot in time, you don't know the information. Like you wouldn't know what was happening in the building. So going maybe maximum 2 years is good. But the last year, if there was no really, let's say, shutdowns in the building or really events that are really affecting the energy consumption in a wrong way, let's say, and that not the normal way or the way the building normally behaves, then we look at the last year. But it's always good to look at many years, 2 years mainly. Going to 3 years and 4 years, you really don't know. The staff was not there probably during these 3 years, so your questions cannot be answered. You're going to ask them, how are you running the building? They probably won't be able to give you an answer. So 2 years is good to look at. If the previous year or the previous 12 months, you don't see any abnormalities compared to the year before, then use that as well. So last year is the one that you normally should use. Looking at different years, it's good to see if that year that you're looking at is actually has good data or not.
Okay, I have a question here. In the case of new buildings, constructions for high-rise buildings or large facilities, is there enough merit to making a case for option 4, calibrated simulation for different stakeholders, followed by M&V to ensure operation as designed, or does periodic retro-commissioning provide comparable results?
Again, retro-commissioning normally looks at energy, but it's not the core of it. Retro-commissioning is mainly looking at systems and making sure that the systems are working properly as per the design intent, as per the base of design, and as per the owner requirements, basic documents. So the OPR basically. But the M&V is mainly looking at the energy. If we are following LEED, normally it is required to go for that. Again, how do you certify that the building has been working properly, or from an energy point of view? If you don't do this, if you don't do the calibrated simulation and then compare it to your model and calibrate the model, and then remove the ECMs from the model to see what is the effect of these really nice ideas that you gave the client and he actually agreed to them, and what is the real effect of those. So this is important to be used. Again, I would recommend this method to confirm savings. The retro-commissioning is mainly making sure that things are working properly. Does look at the energy maybe at a system level, but it doesn't really look at the whole energy consumption. Option D, in this case, if you're really looking at energy conservation and looking at how is your building performing compared to the design, it's probably the best way to do it, going for option D rather than retro-commissioning. Both of them is what we recommend.
Hassan, I have a question here asking about, you've mentioned about the hotel occupancy as M&V. What is M&V recommendation when the hotel completely shuts down during this COVID-19, for example?
Well, yeah, I mean, this becomes a contractual issue between the ESCO and the client. Like, what happens during these things? It's something that it's not like the hotel decided to shut down. There's something like a force majeure happening here. It's more now the contractual issue. Should we just like not include these months at all within the contract and we can resume later? Because the client will say, I'm shutting down the whole hotel. you cannot come to me and ask me for money. I'm not even generating money to give you money. So I've seen this recently with some of the ESCOs, and they're basically deferring it to when the building will operate again. So they're not actually claiming any money or not guaranteeing any savings as well, and then waiting for this to end, then they can restart. It's really hard to say, saying we're saving energy if the whole thing is really shut down, which is happening in most of the hotels. So it's better to defer it to once the hotel operation is back to normal and work it that way.
Hassan, actually, I have quite a lot of questions, but I'm sure that I can send it to you directly to your email, right? Because we run out of time.
No issues, no issues. We can direct them to my email. I'll try to the best of my ability to respond to them.
Great. Thank you so much, Hassan, again, and thank you so much, everyone, for joining. Looking forward to see you again in our next webinar. Thank you, Hassan.
Thank you, everyone. Thanks, Sandra, very much, and stay safe, everyone. Thank you very much. Take care. Bye-bye.
Bye-bye.